Hello students, welcome to Physics Theory, the show where we use cool props and videos in an attempt to get a 4+. You see that? Please give us a good mark. Alright, back on topic. Today we're going to be talking about Newton's 3 laws, specifically applied to roller coasters. Now, we have different people talking about law 1, 2, and 3, so let's start off with first law.
Newton's first law. Newton's first law states that objects in uniform motion or at rest stay in uniform motion or at rest until an unbalanced force acts on it, causing it to accelerate. This is because of inertia. Inertia is a property of matter by which it keeps its state of rest or speed in a direction along a straight line so long as it's not acted upon by an outside force. In the case of the roller coaster, after being pulled upwards to the top of the hill by a cable and is let go, it accelerates. But it gets to a point where its inertia allows it to stay moving throughout the rest of the track and infinitely if possible. After going through all these crazy loops and turns, it has to stop. And how do you stop something that's going really fast and is not planning to stop anytime soon? Turns out there's multiple ways. One of the simpler ways is through friction. As the roller coaster is moving in constant speed and is approaching the end, its wheels rub along the rails, creating heat as a result of friction. This friction slows the roller coaster gradually, as does the air that you fly through when you ride the roller coaster. But as time passes, these friction rails get worn out and in need of replacement, and these rails can be quite expensive to make. So do not fret, there's a more advanced and environmentally friendly way of doing that. Recent technology is using magnetic waves to stop the roller coaster. They work by moving the metal fins through an electric current that does not like change or interruption, until the coaster gets to a stop. But that's for another episode. After stopping, it's going to stay at rest until the new round starts. That's it for first law. Time for the second law.
No, stop. You're not funny. Second law, get in there.
Newton's second law states that when an unbalanced force is exerted on an object, then the object will accelerate in the direction of the force. It also states that the net force equals mass times acceleration. Now, the net force is basically the sum of all the forces that are acting on an object. So an equation that we have for this is F net equals ma, with F net being the net force that we just talked about. Now, in relation to roller coasters, the most traditional way most roller coaster trains get to that first hill is via a long chain or multiple chains that run up the hill under the track, and they simply pull the train to the top. The chain is fastened in a loop that is wound around a gear at the top of the hill and another gear at the bottom of the hill. In simpler terms, the roller coaster basically runs on a pulley system where there's something at the top and then these chains, or in a pulley, they're ropes, they pull something to the top.
A chain, or a pulley system, is an unbalanced force. Because it is an unbalanced force, it is able to change the roller coaster's motion and pull it up a hill. When the force is exerted on the roller coaster moves uphill, in the direction of the force.
Newton's second law also states that the net force equals mass times acceleration, or the infamous equation that we mentioned earlier, F net equals ma. Now, this basically means that the greater the force, the greater the acceleration, since with a roller coaster, once everyone gets inside, the mass will stay constant throughout the entire round.
The mass and the acceleration are directly proportional to the net force, meaning that as the net force increases, one must increase as well to keep the values balanced. When you go down a hill on a roller coaster, you feel a great amount of acceleration, more than you would feel if you just ran down the hill yourself. This is because the roller coaster has more mass. So when the chain pulley system pulls the roller coaster up a hill, the roller coaster changes its velocity, or speed in a given direction, and accelerates and moves up the hill. The harder the chain pulley system pulls, the greater the acceleration. Now, just to explain, acceleration is basically the rate of change in velocity, or the rate of change in speed in a given direction. You also feel this second law when you start going down the hills. The coaster cars and your body have mass. The gravity provides acceleration. That causes force. The rider feels the force as it moves the cars along the coaster track, feeling almost weightless as they move down major drops.
The track directs the force and the cars. The mass of your body and the coaster cars stays constant. The amount of force changes due to acceleration. The changes in acceleration are mostly due to forces like friction. The thrill of acceleration on a roller coaster comes mainly from Newton's second law.
Alright, third law.
I'm not done. There's like a introduction or like I'm supposed to do an outro. Alright, third law.
Newton's third law is that for every force exerted on an object, an equal and opposite reaction force is also exerted.
In the case of a roller coaster ride, the force from the roller coaster pushes onto the air. This results in air resistance. Since there is the force of the roller coaster being pushed, air is being pushed back at you with the same force. Not only so, when you push down on the seat of the roller coaster, the seat pushes back at you. The force of your body mass experiencing gravity is equal to the seat's force pushing back on you. So, when you sit down on the seat, you don't start levitating or sinking into the seat. This is because the two vertical forces are balanced.
You might ask, how is it the roller coaster moving if the same force is being pushed back at it? Well, since air is extremely light compared to the metal that makes up the roller coaster, the force doesn't act significantly on the roller coaster.
As mentioned previously, the roller coaster experiences an opposite force of air resistance. To allow for the ride to go faster and more efficient, improvements in the roller coaster's design can be made to reduce air resistance. One of which is making the cart more aerodynamic. This means making the carts more streamlined and reducing surface area contact with the air. Furthermore, this will also make the carts more eco-friendly, as less material is needed.